Hello everyone and welcome. Today I would like to show you how we can implement our own printf statement, printf function in C language. I'm using GitHub code spaces. I will create a new empty template so everybody can follow along. I think this is a Unix-based system, so it has some advantages. While it's loading, let's talk about what is printf. It's basically how you print stuff in C language, and you can give it some numbers, decimals, integers, floats, octal values. There's U for unsigned decimal. We have hexadecimal numbers, we have floats, we have strings, and we have pointers. So we will implement some of these functions. Let's create a new file in our code space. Install. Okay. To do implement printf. It will have functions like 100d, %d, %o, %u, %x, %c, %s, and %p. So we will be printing integers, octals, unsigned decimals, hexadecimals, characters, and strings, and of course lately pointers. We will try to use as much as libraries as possible, but I want to show you how usually we use stdio.h with main. Let's say printf hello world return 0. I don't know if I think you can guess what this function will give us as output. It will say hello world. Instead of printf, we will working on my printf today, or you can call whatever you want, it's yours. And I would say we can start coding. Let's have a function. If you saw in the documentation, we will use the same format from documentation. In my printf, and it will have some formats, and depending on the situation we will have some extra variables. We will have variable list, and we will call it arguments, and we will have the length of the piece we want to print, and we will use some custom functions for printing these specific elements. Let's define some basic first of all. Decimal base will be 10. We will have octal base, which will be 8. And we will have hexadecimal base, which will be 16, and forward declarations for helper functions will be, we will be printing d means integer, it will have number, we will be printing, octal numbers. Let me just copy and paste here. Yes. So decimal will print signed integer in base, octal will print unsigned integer, unsigned decimal will be print unsigned integers based in base 10. We will have hexadecimal, characters, string, and pointers to print. So print D for decimal numbers, print, which one is next, O for octal numbers, of course, which will have signed long number, we will have int print U for hexadecimal number, again unsigned long number, we will have hexadecimal, print X, it will have unsigned long number, and this time it will also have character type. We will have print char, which will have char character that we want to print, and we have print string, it will receive const char star string that we want to print, and lately we have our printf function, which will be our main function, our main logic, and it will have an arguments list, and depending on the argument type we will call other functions like one of these, and it will basically print what we want to print. So let's continue. We will have variable start, which will have arguments and format, and while our formats list exists, as you can see here, we are getting the format. If it exists, we will check if the format starts with %, because if it's starting with the %, which means like when I say printf, I can also say printf %s and hello world this is another way of let's comment this out for now. And you can see these are the exact same things. If a string starts with % in printf, it means it gives us the format. That means we will check for the letter next. If it's s, it's for string, and we will check at the end of the function calling for what they want us to print. So if we have a %sign, we will move one step ahead. This basically means like array, so that's why we are moving one step forward in the array. We will have a switch case here. Switch, with myself. Switch, we will check for format. We have case of D. In the case of D, our length. By the way, if you've seen it or not, but basically printf is it saying somewhere here? Yes. On success, the total number of characters is returned. So when you are writing what we want to write, we will save the length of the thing we are writing, and we will return at the end. So if case is D, then we will say print D. We will give it the VA args. Let's uncomment this, and we will give it a type of integer, and let's write it more clear, and break case of what's next? O length will be print O. We will give it arguments. It will be type of unsigned. It's one mistake. VA arg. It will be args, and the type will be unsigned integer, and we can break. In the case of U, it's quite similar at this point. Len will be print U. It will want the same argument as O, so I'm just gonna copy and paste, and break. In the case of X, again quite similar. Len plus equals print X. It will have value arg, and it will have value arg arguments, but that was something different. Yes, this time we will also give it char type, so it will be X break, In the case of C, my favorite one by the way, you will see why in a minute, then will be print char, again va args, let's give it an integer, and break case string len plus equals print string, I made a typo, print string, which will have again varg arguments and const char star for string and break. And in the case of P, which will be like the most complicated one, I would say, it will be a little bit more problematic. So we will need an unsigned integer pointer t. Pointer will be unsigned integer pointer t type and va arg. Inside of that we will have args and we will have a void star for the pointer. I think we need the library here. Yes, let's add library. What was it? std int or let's use this. Yes, works. And what was I saying? Okay, in the case of pointer, we have unsigned integer pointer t and length will be print string because we need to print it as a string first, which will print ox. I don't know if you ever seen how a pointer writes. If I say gcc of okay, I will show you later. First, let's finish declaring this. And len plus equals print x. So for printer, basically, we will first print 0x. Then we will print p. That's why also where we said in the print x we will have a char type. If it is x, it will print in hexadecimal style. If it is p, it will be pointer type. And of course, let's have a break. Oops. And as our default, we will have the print char and format. And if format is 100%, we are checking which way we need to print, and let's see, else we will print char star format and we can move a step ahead in the format. when we are done with values, we will end the arguments. Okay, now let's say, what's the problem? I think we need some header files. Unsigned header. I think I have it now. Let's have it. These two. Nope, this is for C++ library. We are using C. And C. stdint.h. I'm calling it actually. Let's check. stdarc. Yes, I think this is the one. Perfect. At least we have different errors. Okay, I think we can quickly make function bodies. Okay, as you can see here, okay, here, first row I print hello world, and in the second row I am printing pointer that shows the hello world, and it starts with 0x and it continues with the hexadecimal number. So that's why, that was the reason why we are giving it here. Okay, so we can start printing the specific cases. Let's start with function to print decimal number. We will have a length that we will return, and we will check if the number we have is less than 0. If the number we are on to print is less than 0, we will say print char minus sign and number equals minus number. Let's say if we have minus 10, we will just take the minus part, put it to the char, and then we will just print, we will just continue working on the negative version of 10. So it will be minus 10, which will be plus 10. I put this here, a small explanation, and we will check if number is larger than equal to decimal base. We will say len plus equals print D number divided by decimal base, and then plus equals print char number modulus decimal base plus 0. What this will do is basically we will check if we have like a big number 1 to 5, let's say. If the number is let's say this 125 is larger than the 10, so we will divide the number by the decimal base. In that case we will have 12.5, and it will be a recursive function. It will call it again, and when it prints it will, and we will, I don't know how to explain, but you will see actually. It will make more sense when you see it. And let's do a print check quickly. It is my favorite because it is only using one line of code. It will say write 1 and character and 1. If you don't know what is the write function, that's what we are looking for. Yes, this one. So write will get the file descriptor, ask a string size of the and size of the string. So it gets. Am I missing header? This one. It's unistd.h to have it. No, let's edit. Also, we can give these maybe explanations why we have it. We had this for this reason. Let's see the arguments for to be able to use VAs, VA list. And others, and we are using for this for the write function. So in our char, now you can see it will get n bytes of buff to a file descriptor and return number written or -1. So the file descriptor will be 1. The character we will give it, and it will print only one character. So let's say it will just print A. And in this context it should work. Let's comment this out and say my printf, we will give it %d, and I will give it 1, 2, 3 as a number. I think this should work. gcc main a.out, and we are successfully printing our decimal number. As you can see, we are almost finished with we are already almost finished with the function. Great job. And also we can test our print character. Why not my printf %c new line, and I will give it a mean a.out, and we are successfully printing our character and our decimal number. I don't know if you noticed, but when I say print %character and new line, first it checks for the % sign, it finds it, it checks, oh, there's a C, so I know I will need to print char. Then it prints it, then it moves to the next one. We are going out of the if loop. In the else, it says, oh, okay, there's a new line character, new line char, so it just prints the char. So it is like more complex than it seems maybe, but I like it. It's nice, it's fun. It gives you a chance to learn how some stuff are working. And let's continue with the function to print an unsigned octal number first we will check if number is 0. If that's the case, we will return print char and just give it 0, and int length equals 0 octal int octal digits, which will have 32. And it will be array of the integer, and we have int I equals 0, and we will return length. Okay, so while our number is larger than 0, in the octal digits array, we will increment the number will be the modulus of the octal base that we declared earlier, which is 8, and number divided equals to octal base. Nice. This will basically help us. Is there an example for the octal base? Yes. If you see in which one? Yeah, some different radices. The first one is 100 in decimal base, second one is 64 in hexadecimal base, third one is 144 in octal base, but they are all 100 in the decimals. So that's the simple math. You can look further into it, but like this is a simple way to explain what we want to say. And while I minus minus, so first, while number is bigger than 0, let's say 100, we are getting the digits for our octal digits array, integer array. We are saving the modulus of the numbers in the octal base, and we are dividing the number by the octal base, and we are incrementing the I to the end. And now we will go back step. While I exists, length will be print char octal digits of I plus 0. So we are also done with our print O. Let's see. My printf %o new line, if I give it 100, we know it's supposed to return 144, I guess. Yes, perfect. Also another way to be sure if everything is working, we can print one of my printf and one printf and compare the results. And yes, as you can see, my printf prints A, printf prints A, my printf prints 1, 2, 3, printf prints 1, 2, 3, my printf prints 144, and printf prints 144. Nice. Let's continue to the next implementation, which will be the function to print an unsigned decimal. I will say return print the number. This is my favorite. That's all. I'm not kidding. We can give it a try. Is it here? Let's find it. Percent U. No, we cannot find it. Why? It's like, yeah. Okay, let's print it. I will say my printf %u new line, and what was the name? 7235 7235 and printf %u, of course, new line 7225, the opposite, 7235, sorry, 7235. Let's GCC print. Yes, it is also working for unsigned integer. Now we have print hexadecimal and print string left. I think print hexadecimal is the most confusing one, so first I will do print string and be done with this. It will be an if statement. We will check if string exists. We can say if string null, return write 1 to the file description. We will print null and 6. That's how it works in printf. Let me show you. Printf %s null. If you say this, okay, now we have some automatic flags. They don't even let me print this, but usually if there's no flags and when you GCC, if you try to print null, it will only print like null in parentheses. I don't want to now deal with the flags, so I'm just gonna skip. And what's next? if it's not null, then we will return write the file description, string what we have, and we will need to give it string length. So usually use str length and create the string, but I am against using extra functions at this point because we already made so many functions as of, so why not also make the str length function. So as you can see, write once size t of the n of the string we are giving. So I will say size t my str length, it will have char star string, actually const char star string, and size t length equals 0, return length, while string length x. I don't want to make a mistake because people make mistake in the smallest parts and I don't want to do that. So I will quickly check. So size t len equals 0, while string, yeah, we can just say pointer to string exists, len will be plus plus, and we will move a step ahead in the string, and we can return length. So let's say my str length. This should also work for printf. Let's give it a try. My printf %null and new line, of course. It's working. Let's also give it a value this time. I will say hello world. Yes, my printf string function also works. We can print strings. And finally we are in the complicated part, but also the last part, then we can finish this project. Print x also function to print character my str length function implementation of strlen. So we are implementing ourselves, so we don't have to call string header in C. It is better. I prefer doing this kind of small functions myself. And print string function to print a string and my printf, of course. What's that? Okay, it can stay. And print x function to print a hexadecimal number, and it will check for the number. That's what we always do when we have big numbers. If number is 0. In that case, we will just return print char is kind of just print 0 if the number is 0. If not, we will have int length equals 0, int hex digits, it will have a 32 base array, and we have int I equals 0 digits. We also did something similar in the octal numbers, and we will check characters char offset, which will check if the type is equals to P. If not, it will be A, and I think I can write this clearly. Yeah. Let's check this, because also in Python maybe you heard like lambda functions, or this is just a simple if statement, but I don't want to use it right now. So what we do is we have char offset, it will check if we want to use uppercase or lowercase hex letters. Uppercase or lowercase hex letters, and we will choose the letter case. We will check for if it's P, if type equals P, it offset will be A, or else offset will be A, because let me show. When we say printf, is that example? %x line let's get 100. I don't know what it will return. So it will be 64, I guess. Let's see. Yeah, it is 64, but we want to add something hexadecimal. Yeah, I will show you later. At the end, when we are testing everything, I will show you. Then. Okay, now we know if you want to, if we will print lowercase or uppercase. If the type is P, in that case we will be printing for a pointer. And if else, we will print it for hexadecimal. That's like that's checking for how to say A or A for hexadecimal digits above 9. Okay, so we will convert the number to hexadecimal by repeatedly dividing by 16 like we did in the other ones. So I will say while number is larger than 0, we will have a remainder, and it will be the remaining part of the number modulus hexadecimal base, and we will check if remainder is less than 10 hex digits. We will move remainder. We will sync remainder plus 0. That's how we are converting to a digit character. Else, what we will do, we will get hex digits. And if remainder is larger than like 10 or larger, which like what I said here, A or above 9, we will also move a step ahead in the array, and we will say remainder minus 10 plus offset. It should be A or A depending on the situation. And still inside of the while loop, we will say number equals number is divided and equals to hex space, and then we will print the hexadecimal digits in the reverse order like we did in the octal numbers. So I will say while I minus minus exists, also we did here, or you can say while I is bigger than 0, same thing. Also let me put this here, so if someone reads later they can understand what I meant. If I is bigger than 0, len plus equals print char, and we will give it hex digits, and it will be in the reverse order. So yeah, actually we don't actually want to decrement when we are printing. Like we can say this, like we can, when we say minus I minus minus or minus minus I can just say I, but just to be more clear, I will say while I is larger than 0, we will decrement and print in reverse order, and of course when we are done, we are returning the length that we are printing. And I think this was all. Like we have our completed printf function. We are printing decimals, octals, unsigned integers, hexadecimals, pointers. Now we can just try to test it. I had a long test line I made earlier. Let's try. So we will try decimal, octal, unsigned, hexadecimal, characters, strings, pointers, and we will print the pointer to the main. Let's say gcc a.out, and let's have the same one. With the printf, so we can compare. And as you can see, my printf and printf has the same values, except why my hexadecimal is in lower cases, upper. Let's call the calculator. And we were, for the hexadecimal, we were trying to print, and in the calculator I don't know why. Yeah. Oh, okay, because it is like checking for uppercase or lowercase. I don't think it matters, because if I say uppercase X, yes, it will be the same. We can quickly modify this. I will just we can just check for if type P or type equals X, and save it twice. First, let's print small x, then big X. What's the problem? Oh, of course. And let's also do it one more. There and there. GCC a.out. Okay. One, two, three, four, five. I made a mistake. This is what we were supposed to try to print. And GCC a.out. Okay, now also small x and large x is working. So thank you for watching. In this, I think, 1 hour video, we talked about how we can implement our printf, what printf is supposed to print. We talked about the bases, the functions that we use to print the asked style type of numbers. And if you have any questions, you can ask me in comments. I will post this. I will post this in the comments. I don't think there's a need for GitHub. This is only one file with almost 200 lines of code. So thank you for watching. I hope you enjoyed it, and see you next time.